How many alien civilizations are there? Are we truly alone in the universe? It's a question that's fascinated us for generations, and one that feels more urgent than ever as we scan the stars with powerful telescopes and send signals into the void. The universe is mind-bogglingly vast, with billions of galaxies and trillions of planets. Even if life is incredibly rare, say, just 1 in a million planets, it still seems likely that intelligent civilizations should be out there. So why haven't we heard from anyone? To move beyond guesswork, scientists have turned to math. The Drake equation offers a structured way to estimate how many alien civilizations might exist by breaking the problem into smaller, measurable parts. Stick with us until the end of this episode to delve into all of these. If you're intrigued by the mysteries of the cosmos, don't forget to subscribe to the UFO Universe channel for more exciting explorations into the unknown. Our exploration begins with a puzzling contradiction: the difference between what statistics suggest and what we actually observe. If intelligent civilizations are supposed to arise on just 1 in a million habitable planets, then in a galaxy filled with around 100 to 400 billion stars and possibly trillions of planets, we should expect to find thousands, if not millions, of alien societies around us. This astonishing possibility makes the eerie silence of the universe all the more unsettling. This conundrum is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked in the 1950s, "Where is everybody?" To tackle this paradox, astronomers and physicists have tried to calculate the odds of intelligent life using various tools, including the Drake equation, created by Dr. Frank Drake in 1961. This formula estimates how many civilizations in our galaxy might be capable of communication. It incorporates several important factors, some based on solid astrophysics and others more speculative in nature. Yet, even with conservative estimates, the calculations often suggest numbers far greater than 0. So why are we not hearing from anyone? One explanation is that civilizations could have existed long before humans emerged and have since vanished. Cosmic timescales are vast, and Earth has been around for 4.5 billion years. What if entire civilizations lived and died millions or billions of years ago, long before humanity even discovered fire? This introduces the concept of the temporal window problem. We may be late, or perhaps too early, to the galactic party. As astrophysicist Avi Loeb put it, the silence may simply mean we're not looking at the right time or in the right way. Next, we dive into the framework of the Drake equation, a tool that attempts to illuminate the possible paths to alien communication by breaking the mystery down into smaller, calculable steps. In 1961, astronomer Frank Drake formulated the Drake equation, an attempt to quantify the number of intelligent, communicative civilizations in the Milky Way. Rather than guessing outright, the equation breaks the process of life and technological intelligence into 7 sequential steps, each represented by a variable n equals r, x f sub p, x n sub e, x f sub l, x f sub I, x f sub c, x l, in which n is the number of civilizations in the Milky Way galaxy with which communication might be possible, r is the average rate of star formation in our galaxy, f sub p is the fraction of those stars that have planets, n sub e is the average number of planets that can potentially support life per star that has planets, f sub l is the fraction of planets that could support life that actually develop life at some point, f sub I is the fraction of planets with life that go on to develop intelligent life, civilizations. F sub c is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. L is the length of time for which such civilizations release detectable signals into space. Input a few plausible values, and you'll arrive at a figure perhaps in the hundreds, thousands, or even millions of civilizations within the Milky Way alone, which is just one among countless billions of galaxies. However, there's a significant issue. We lack certainty about most of these values. Some, such as the number of planets per star, are now easier to estimate due to exoplanet surveys. It's likely that most stars host planets, and perhaps at least 1 in 10 of those systems has a planet similar enough to Earth to support life if conditions were right, potentially. On the other hand, factors like the probability of life emerging or intelligent life developing remain complete enigmas. We might convince ourselves that these probabilities are 1 in 10 or 1 in 100, similar to planets, but any of these unknown factors could just as easily be 1 in 10 quintillion, making the existence of even one species like ours in the galaxy, or the entire observable universe, extremely unlikely. Even slight adjustments to these numbers can drastically alter the outcome. If life is abundant and civilizations endure for long periods, the galaxy should be teeming with activity. Conversely, if intelligent life is extraordinarily rare, we may be truly alone. The reality is that the Drake equation isn't truly an answer. It's more of a guide, highlighting the gaps in our understanding and pointing out what we need to learn to uncover the truth. While it has its shortcomings, as discussed in the episode dedicated to it, it serves as a fairly reliable framework. However, it offers no insight into how alien civilizations might behave once they develop advanced technology and begin exploring the cosmos. Picture an alien species that is 1 million years ahead of us. Would they be illuminating the skies with massive structures or quietly observing from the shadows of the universe? So, do these calculations imply the universe should be teeming with alien civilizations? Or is the silence we observe already the answer? To gain a clearer perspective, we must turn to a different model, one that proposes the most conspicuous alien civilizations would be impossible to overlook: Grabby Aliens and the expansion hypothesis. If Grabby Aliens exist, then the night sky wouldn't appear dark and empty. Instead, it ought to resemble a glowing cityscape as seen from orbit, or a blur of infrared heat signatures, not the cold silence of a cosmic wasteland. If advanced civilizations tend to expand across the galaxy, wouldn't we expect to see clear signs of their presence everywhere? And if we don't, what might that imply about our own future? The Grabby Aliens Hypothesis offers a unique perspective on estimating alien civilizations. Instead of focusing on how many intelligent species exist at any given time, it examines what would happen if even a small percentage of them became highly expansionist, aggressively colonizing new planets, altering their environments, and leaving unmistakable evidence of their existence. Essentially, what we might call loud aliens, but amplified to an intergalactic scale. If such civilizations emerge, they wouldn't just be noticeable, they would be impossible to ignore. This concept, introduced by Robin Hanson, a physicist, economist, and long-time thinker on the Fermi Paradox, proposes that once a species reaches a certain technological threshold, expansion becomes the natural next step. Similar to how humanity has spread across Earth, these grabby civilizations wouldn't remain confined to their home planets. They would expand into space, gradually claiming more of the galaxy. Here's where it becomes fascinating. If such civilizations exist, their expansion would be constrained by the speed of light. Their ships couldn't exceed this limit, and their colonization processes would likely be even slower, accounting for settlement growth and infrastructure development. However, we can estimate a plausible expansion speed, whether it's 1% of light speed, 99%, or somewhere in between, and use that to predict how far these civilizations could have spread by now. A single grabby alien civilization could reshape the cosmic landscape, establishing empires larger than entire superclusters. Over time, this expansion would divide the universe into distinct territories, with each civilization racing to claim as much space as possible before encountering others. Naturally, the universe's expansion adds a layer of complexity. Regions far enough away are moving apart faster than the speed of light due to cosmic expansion. However, at the current rate, this effect only becomes significant at distances of roughly 1 billion light-years, where it reaches just 7% of light speed. This means it would pose little limitation for civilizations expanding even on the scale of superclusters. If some alien species started their journey 4 or 5 billion years ago, back when the universe was denser and galaxies were closer together, their influence could now span an extraordinary range. Moreover, if even one ambitious civilization started expanding billions of years ago at a significant fraction of light speed, it would be highly unlikely that we'd be the sole inhabitants of this galaxy. Such a civilization would have had an immense advantage, making it improbable for any new species like ours to emerge without already existing within their territory. On a supercluster scale, we would expect to see undeniable signs of their presence, such as galaxy-wide megastructures, transformed star systems, or an overwhelming influx of radio signals. Yet, as far as we can observe, the stars remain silent and space appears untouched. So, why is this the case? There are a few potential explanations. First, they don't exist, or are exceedingly rare. This could mean that intelligent life is far less prevalent than we assume, or that there's some unknown barrier preventing expansion. Secondly, they haven't reached us yet. Perhaps we are early, and the first expansive civilizations are only now beginning their cosmic journeys. Thirdly, they expand in ways we don't recognize. They might not rely on Dyson spheres, or radio waves, or they could intentionally avoid detection. Next up, something stops them. Self-destruction, an unknown filter, or an active effort to prevent expansion may be halting civilizations from becoming dominant. In Hansen's model, he examines a variety of potential expansion speeds, but suggests that it doesn't take long for spacecraft to reach their maximum achievable velocity. On a galactic scale, if the speed of light is the ultimate limit, then within a few thousand years, any highly advanced species would likely have optimized their propulsion systems and continued expanding at that speed, or whatever the practical maximum may be, likely somewhere between 1% and 99% of light speed. Although they might begin slowly, the time required to reach a steady expansion speed is relatively brief on galactic timescales. While we can't determine exactly how fast a civilization might expand, Hansen considers several scenarios. One of his widely discussed estimates assumes a colonization speed of 80% of light speed. Based on this model, he calculates that for our existence not to be an extraordinary anomaly, where by chance most superclusters host at least one civilization, but none emerged near us, there can't be more than roughly 10,000 civilizations actively colonizing the galaxy. Of these, nearly half likely haven't begun yet, meaning we've arrived slightly beyond the midpoint of the process. If this is accurate, there may still be time for humanity to claim a supercluster-sized region, placing us on the slower end of expansionists, though not excessively so. However, this is purely a probabilistic argument. We could just as easily be the very first civilization, or one of the last, perhaps close to number 9,999. In the absence of evidence to suggest otherwise, the default scientific position assumes that we are typical. This is the foundation of the mediocrity principle, also known as the Copernican principle, which posits that unless specific data indicates otherwise, we should regard our place in the universe as unremarkable. At first glance, the notion that we might be the sole intelligent civilization within a supercluster containing a quadrillion stars seems almost absurd. However, sheer numbers shouldn't overwhelm us. After all, the universe is unimaginably vast. When we explain that the Grabby Aliens model predicts the existence of several thousand ancient alien civilizations, it often seems plausible, perhaps even generous. Yet when framed differently, such as suggesting there are none within our galaxy, or among the million nearest neighbouring galaxies, it suddenly feels astonishingly low. Despite the shift in perspective, the figure remains the same. Currently, estimates suggest there are approximately 2 trillion galaxies, a number that has doubled over the past decade due to advancements in telescope technology. Many of these galaxies are so distant that we observe them in their infancy, before countless cosmic mergers transformed the universe. Let's assume that the total number of intelligent civilizations that ever emerged and became expansive before encountering another similar civilization is around 7,000. On average, each of these civilizations would have the opportunity to claim approximately 300 million galaxies before meeting another. Naturally, this is just an average. Early expansionists would have access to more, while civilizations that arise later would not only face less available space to expand into, but also have to deal with increased cosmic expansion, making it more challenging to reach new galaxies before encountering another advancing empire. Of course, this comes with several assumptions. For instance, the estimate of 80% of light speed is somewhat arbitrary. While I think it's a reasonable figure, it's mainly because I expect most of the travel time for colonizing worlds to occur intergalactically, involving incredibly costly megaships, traveling at speeds close to 99% of light speed. Even so, a compelling argument could be made for settlement speeds being as low as 1%, or even 0.1% of the speed of light, a process often referred to as colonizing the galaxy, which is covered in its own discussion. For instance, if civilizations began expanding at 10% of the speed of light approximately 2 billion years ago, they would have reached a maximum distance of about 200 million light-years from their origin. However, the actual distance would be slightly less due to various factors. At such vast distances, the Hubble expansion becomes significant, gradually reducing their ship's effective speed to about 8% of light speed. Beyond a billion light-years, the universe's expansion surpasses their ability to travel, effectively preventing colonization beyond that range, since their ships could never bridge the increasing gap. The observable universe encompasses a staggering volume of roughly 4.21 times 10 to the power of 32 cubic light-years, whereas the 200 million light-year settlement bubble previously mentioned occupies a comparatively smaller volume of 3.35 times 10 to the power of 25 cubic light-years. While both figures are unimaginably large, the observable universe is vastly more expansive. Dividing these values yields a ratio of approximately 12.6 million, indicating the observable universe is 12.6 million times larger in volume than a single settlement bubble of that scale. Although this is a simplified model compared to Hansen's more detailed calculations, it provides a reasonable estimate. At 10% of light speed, the number of advanced Grabby civilizations increases from a few thousand to several million. If the expansion speed is reduced to just 1% of light speed, the potential number of such civilizations skyrockets to several billion. Since volume increases with the cube of distance, reducing the expansion rate by a factor of 10 means each civilization occupies only 1,000th of the available space. This implies there's room for 1,000 times more civilizations. However, this doesn't confirm their existence, only that such a number could theoretically exist before encountering implausibility. Otherwise, we would have observed or interacted with one by now. In fact, a highly advanced civilization might dominate its entire galaxy, perhaps even extend its reach to a small cluster of nearby galaxies. But the notion of controlling an entire supercluster seems implausible. In such a case, billions of alien civilizations could theoretically exist without ever crossing paths. However, it becomes increasingly difficult to argue that they haven't observed one another, or that we haven't observed them. When we examine hundreds of thousands of galaxies and detect no signs of Kardashev-scale megastructures, the key issue isn't whether we or they could physically traverse the vast distances at 1% of light speed. The real puzzle is, Why hasn't evidence of their existence, such as the light from their civilizations, reached us? If advanced civilizations were constructing massive interstellar projects, we would expect to detect some indications, be it enormous Dyson spheres around stars, peculiar infrared signatures, or galaxies altered by alien engineering. However, the universe remains hauntingly silent and seemingly untouched. The limits of detectability. Why can't we find them? It's worth questioning whether our search methods are appropriate. Most attempts to detect alien civilizations have focused on radio signals, yet an advanced species might use entirely different technologies, optical lasers, neutrino transmissions, or even communication techniques beyond our comprehension. Instead of listening for extraterrestrial radio signals, our best approach might involve searching for artificial structures, waste heat, or Dyson swarms using infrared and next-generation telescopes. This aligns with how we typically detect intergalactic phenomena. We look for observable changes in galaxies that could represent the byproducts, waste, or activity of large-scale civilizations. Highly advanced civilizations, such as Grabby Aliens, would likely become visible once they colonize an entire galaxy. Any region of space visible to us today, excluding areas so distant that the light we see reflects events from billions of years ago, should reveal signs of such civilizations if they exist. Beyond those distances, we're essentially observing ancient history. We don't observe alien life because we're looking so far back in time that it might not have developed to a detectable scale yet. Rocky planets capable of supporting life were much rarer in the distant past, and even if life emerged, it would need eons to evolve into advanced civilizations capable of building spaceships or colonizing galaxies. For these considerations, we must set aside the Grabby Aliens framework. In scenarios where civilizations expand at 1/10% of light speed, the observable area of an alien civilization, defined as the region where we could detect its presence through light or signals, is now significantly larger, over an order of magnitude wider, and thousands of times greater in volume than the space it has physically settled. The Fermi Paradox isn't about the size of an alien empire, but whether we can detect it. Even if millions or billions of civilizations exist at these settlement speeds, they couldn't be much more numerous than our initial estimates without us already noticing their home galaxies. While their empires might expand slowly compared to light speed, the signals and evidence of their existence, such as light or other detectable signs, travel at light speed. If any advanced loud alien civilization had emerged nearby, their monumental engineering feats, like Dyson spheres, stellar reshaping, or galaxy-scale modifications, should be visible. Nevertheless, after scanning hundreds of thousands of galaxies, we've found no clear evidence of such activity. In addition, the detectability of civilizations largely depends on whether we are searching for at least partial Kardashev 3 civilizations, those that have significantly transformed their home galaxy's emissions through widespread colonization and the construction of megastructures. Under this assumption, it's plausible to estimate that 1 trillion alien civilizations could exist, approximately 1 per galaxy, with some galaxies hosting none and others accommodating 2 or more. We don't observe them because from galaxies away they remain relatively inconspicuous, even if they have colonized most habitable planets in their galaxy. None of them appear to have reached Kardashev 2 status around any individual star system. Notably, this perspective doesn't imply we share the Milky Way with anyone else, or at most perhaps a civilization as young as ours located on the galaxy's far side. Nevertheless, this scenario still suggests over 1 trillion alien civilizations. In truth, what we're discussing here are expanding alien bubbles rather than unified civilizations. Without faster-than-light, FTL, travel, a truly unified interstellar civilization is as unlikely as a single global civilization existing on ancient Earth thousands of years ago. Even a hive mind species, dedicated to galaxy-wide colonization and replicating itself precisely at each stage, would likely fragment over time, especially at the scale of a supercluster. Beyond a local cluster of star systems, maintaining a single, cohesive civilization becomes increasingly improbable. In reality, a single star system could give rise to numerous independent civilizations, possibly even millions in extreme scenarios. This suggests that a single galaxy might hold trillions of unique civilizations, all tracing their origins back to the same original homeworld in the distant past. And that's not even accounting for artificial branching like an advanced AI choosing to separate and build its own society elsewhere in the galaxy, or genetically uplifted animals such as chimps, dogs, or cats who decide to leave human-dominated regions. Then, perhaps thousands of years later, uplifted dogs might create uplifted squirrels, who in turn choose to establish their own territories beyond dog-controlled space, leading to an ongoing cycle of divergence. When you scale this up, the numbers become staggering, potentially more than a trillion civilizations existing across the universe, whether now or in the far future. Many of these would undergo profound changes over time, evolving into entirely new forms of civilization again and again before their host stars eventually burn out. Of course, not all civilizations choose to expand. There are alternative paths. We shouldn't assume that every alien civilization will take the Grabby Aliens route, even if they can. Generally, about 1/3 might become Grabby Aliens, another third could self-destruct, and the remaining third might decide not to expand for various reasons. Those that choose to stay put might eventually be absorbed, ignored, or eradicated by an expanding Grabby alien empire. However, by the time this occurs, the Grabby civilization may have evolved so much from its original state that it no longer perceives these non-expanding aliens as threats or obstacles, or any more alien than its distant relatives in other star systems. It's also important to consider the timeline of intelligence on any given planet. If we consider a planet's evolutionary timeline as spanning 1 billion years, progressing from simple algae to an interstellar civilization, then only about 1% of that time would involve anything resembling human-level intelligence, even generously including dolphins and chimps as a benchmark. Furthermore, only 1% of that 1% would represent the period during which such a civilization possesses the capability to interact with others. This implies that for any life-bearing planet destined to eventually produce a Grabby alien civilization, the likelihood of encountering another expanding civilization during its brief pre-spacefaring phase is approximately 1 in 10,000. Even on planets that support life, most would likely be home only to alien ecosystems, not advanced civilizations. As for why some civilizations might choose not to expand, aside from the risk of self-destruction, there could simply be those that opt against it. Certain species might find space travel undesirable, while others, such as hive minds, might avoid settling beyond their zone of direct control, fearing that distant colonies would inevitably deviate from the original collective. This reasoning also applies to interstellar bubble civilizations, IBCs, which we've discussed previously. These are civilizations that achieve spacefaring capabilities but intentionally limit their expansion, whether for ideological, practical, or strategic reasons. Some may exist as post-scarcity societies with no drive to expand, while others might adopt an isolationist stance, perceiving the galaxy as a hazardous place. Some civilizations might prioritize strict internal governance, aiming to maintain a stable and unified population and culture rather than risk fragmentation through unchecked colonization. Alternatively, they may have determined that the universe is currently free of threats, but if they continue expanding indefinitely, it could eventually lead to danger. As their distant colonies evolve, they might inadvertently create future competitors around themselves. To avoid this, they could deploy automated resource harvesting machines, to strip mine a buffer zone surrounding their controlled territory, a barren, lifeless area that still appears to host normal stars, but has been depleted of essential resources like asteroids and accessible fuel. This region could be referred to as the desolation zone. Such a strategy would make it much harder for a new civilization or an invading force to quickly establish themselves nearby, granting the IBC civilization additional time to respond to any unwelcome arrivals or rogue elements before they pose a significant threat. It's conceivable that there could be 1 million interstellar bubble civilizations, IBCs, in this galaxy alone, and even if only their core systems or a few nearby stars were converted into Dyson swarms, they would likely remain undetected by us. These civilizations align closely with the concept of a classic space opera-style interstellar empire. For instance, a core system might feature an advanced Dyson swarm composed of a quadrillion large space habitats supporting quintillions of inhabitants, or perhaps a colossal Matryoshka brain intelligence. Surrounding systems could host billions of people each, functioning as rural outskirts or independent renegades, depending on their structure. Each of these systems could represent an entirely autonomous civilization, and within a single star system, located in a so-called desolation zone, there might even be hundreds of such civilizations, proving that these zones aren't necessarily barren. What does this imply for humanity? Primarily, it's positive news. It's possible we are the first intelligent life in the universe. But even if there are thousands of other civilizations, there are still millions of galaxies available for us to explore and claim without needing to compete or conflict with alien civilizations, at least for now. Naturally, humanity might just keep up its age-old habit of internal conflict. But even if intelligent alien life is far more widespread than we think, that could still end up working in our favour. Suppose we only get control over one galaxy, or even just a portion of one. That still means we'd have access to trillions of worlds. Even in a limited expansion model, like the interstellar bubble civilization, IBC, scenario, our species could still grow to be millions of times larger than it is now. And the outlook is even more optimistic if advanced civilizations prefer tapping into richer parallel universes instead of settling ordinary space. With trillions of galaxies and countless stars out there, maybe only one civilization, ours, is gazing into the cosmic void. Personally, we think the Grabby Aliens theory is most plausible. If civilizations expand at even 10% the speed of light, then it's possible that only 1 in 1 million galaxies has ever produced intelligent life, perhaps just 1,000 civilizations in total, or even only one. So the great silence we observe could mean we're entirely alone, or simply among the first. Either way, the future appears to be ours to shape. And this wraps up today's episode on the UFO Universe channel. Thank you for your time and curiosity. If you found today's revelations about aliens and unidentified phenomena exciting, go ahead and like this video and subscribe. You won't want to miss the next astonishing discovery or theory. Our universe is full of secrets. Let's uncover them together, one episode at a time.